Hi everyone, my name is allenaltiner. I'm currently working in the gaming industry as a 2D, 3D conceptual designer, and I've done work in film and gaming and advertising for the last 15 years. My interests are in artificial intelligence and neural networks, and today I wanted to share something very exciting, and I will include the link to the site and also additional links that relate to these neural networks and other information that may be useful to you. I also want to talk about the channel that I'm running is Artist Cafe, and Artist Cafe is basically an invite-only social platform, and I do have a lot of different videos on my personal experiments with 2D and 3D, but Artist Cafe is basically the community where I share free models and assets and also invite individuals that are just very passionate and want to be part of a very, very positive and sharing community that sincerely cares about other artists. And there's also a lot of other job opportunities, and you can check that out, and the links will be probably included at the bottom of this video. So I just want to go back to distill.pub, so I'll include the link in the comments, so you can actually go directly to the website. And I basically have found and learned a lot of stuff, and this is pretty amazing. This paper includes a ton of new information that I think is going to change the way we work in the industry and allows for AI to assist and help us work more efficient and faster, and even create new ways of working, because I really believe that new ways of thinking will always enable new discoveries for us and techniques that we can explore and utilize. So I just want to talk about what this dives into. So this paper basically talks about how a parameterized approach or changes can drastically improve the optimization of 3D neural art, which is these light images. And I'm sure you've seen a lot of websites that kind of utilize that. And also how these style images can be used to create really good texturing for 3D objects as well as animation. So I just want to basically start with, they have this in sections, which is great, and it dives into VGG architecture, which is, VGG stands for Very Deep Convolutional Networks for large-scale image recognition, and it talks about the advantage of this, since other agents and neural networks are discarding this information. So let me get into the first section. So they have it in sections, which is really nice. And I personally have been into AI technology for several years, but the more you read and learn about it, as I'm also taking classes on the subject now on machine learning, I think every artist can learn these things, and we can all get together and just create these exciting new ways to create artwork, both 2D and 3D. So I'll talk about the first section. There's a lot of information here, so I will just do a summary of it, and you can go in and spend some time on your own to read more about it. The link will be in the description. So I will start with section 1, which basically talks about aligned feature visualization interpolation. So what this talks about is two different versions of these interpolations. So one is a unaligned version, and then the other one is a aligned version. So what these neural networks are basically looking for is the visual landmarks in the images that we're feeding in. Obviously, it's picking up the eye in this case. And so these networks are always looking at landmarks, and then eventually the neural network looks for aligned interpolation. So the goal would be to create aligned interpolation using shared parameterization, which is awesome, because the end results is avoiding these flickery images, which the next section talks about. So in here, I just want to basically hit play so you can see that the reason it's twitching or it's basically flickering, because it's just individual networks being played back and forth here. And you can see that each network is focusing on an eye, and we're just basically looking at both the unaligned and aligned interpolations of these outcomes. And then on the next step, you can see that it basically talks about the sharing parameterization, which really helps align these neurons and give us an output of these still images. Let me pause these guys. And the second section is really exciting. So this is basically talking about style transfer with non-VGG architectures. And in this case, due to the large image size of these VGG architectures, they end up collecting so much more data and capturing more information that other models are discarding. Okay, so they have some examples here for both style image and content image from what they have been training these neural networks with, and you can see that the final optimization is pretty impressive here. So transferring the style image to the content image, the data basically gives us a style image that can be utilized. Figure 5 goes in and shows you how this process is basically achieved and the end result of it. And section 3 talks about CPPN, which is compositional pattern producing networks. Using CPPN as an image parameterization adds like artistic quality to these neural art, or let's call them like light paintings. That's what I'm reading, what most people call them. So CPPNs are like neural networks that map X and Y positions to image colors, and then this is actually explained up here. The CPPN creates that, and then the XY is converted with the CPPN to RVG. And this is where things get really exciting, and you can see a lot of different type of image results in here, which also can be animated. So you can basically create morph targets from all these different data outputs from these neural networks to animate them. It basically really morphs, one information towards the end of the information, what's been collected from the neural networks. And then here they've included some animations that you can kind of see what that does. And deep art websites have showcased this already with a lot of examples, but this is more going into the technical part for artists to be able to actually take advantage of this type of neural network training to create different processes, right? So section 4 talks about generating semi-transparent patterns, and this is pretty amazing. So once you feed in the alpha information as well, what happens is, like, here's an example. I'll just go back to the white frame, and then if I go into the opaque versions here against black, you can see that's basically the style transfer. But then if I click on transparent and I pull this to the mask area, you can see that the transparent information, the alpha channel information, is in there. So this is pretty interesting because this could be really utilized to maybe create a lot of decals and different kind of material shaders that could be experimented with. So this I find is really fascinating. So the neural networks are basically used in these entire images to train and receive like 2D RGB images as input. So adding an alpha channel to the image parameterization gives you a lot better results that I just see could be somehow utilized as this industry grows and there's more people working on this. And there's a couple more examples here of neuron visualization with transparencies. The last section is the efficient texture optimization through 3D rendering. So this is the most amazing section that I find really interesting. So there's two ways that this is done. One is the naive optimization, and then the other one is the render-based optimization. So the naive version is just basically straight image. If I unfold the texture, you can see that there's no UV information being taken into consideration, but then on the render-based optimization, you can see the result here. So they're pushing this idea further, and they're basically using 3D rendering process to turn them into 2D RGB images that can be fed into a neural network and then back propagate through the rendering process to optimize the texture in 3D. So if I use the famous Stanford bunny here, go back to unfold, you can see that the 3D image. Let me zoom in a little bit. You can see that it did a pretty good job. I mean, you know, there's a couple areas when I zoomed in that I saw in here that look like they are actually cutouts, but overall, in the next section, they're gonna show us more on what's possible, unfolding different textures. This is something that I find extremely useful. I just myself need to study this more and just really look into it and understand how this could be utilized. And then the last section is the style transfer for textures through 3D rendering more in depth. So they're basically really getting into how this all works and how it could be utilized, given examples with style images and content models. So the style images are basically, if I scroll back up, these were the style images that were created, and now we're basically taking style images. Let me go back up, and as you can see, there's different style images here, right? But now, given this data to the content model, so if I change the model here, in this case the skull, it perfectly gets it onto the model. So these are like these combined stages, obviously throughout the entire paper, that shows you what's possible, and this is pretty amazing. I mean, this is it's just really mind-blowing stuff. So what's really the conclusion? I will include a bunch of links here. I think the conclusion is that the future is really exciting for both film VFX artists and gaming artists to utilize neural networks for creating more efficient and faster workflow for production, and also animation and 3D objects. And I personally really like the creation of style images and content images, as I have been actually experimenting with this, and I will share some of the results. But overall, thank you for watching this. I hope that this was interesting, and check out the links in the comments. I will also include some websites that are already using this technology and how it can maybe help you with the creation of your artwork. Thank you so much, and stay healthy, everyone.